there are highly polar molecules and there are molecules that are not polar at all. And the highly polar molecules don't like to mix with the molecules that are not polar. Okay, that's why oil and water don't mix. Okay, well, how do you figure out when a molecule is polar? There are two conditions for figuring out if a molecule is going to be polar. This is a very simplified system because it gets way complex if you get the larger molecules. But the first thing is you have to have, let's see, for a molecule to be polar, must have one polar bonds, and two, an uneven arrangement of those bonds. Okay? Polar bonds and an uneven arrangement of those bonds.
Have you ever felt like you got tired of speaking?
Yeah. Every day in here with Nigel. I'm kidding. I'm joking. Okay. Now, believe it or not, I even like Nigel. I don't like Nigel, yes. Even hey, believe it or not, I even like Tori. You know?
Don't play like that, dog.
Okay?
No Penn State.
I like Richie over here.
This dummy said no Penn State. Are you really?
And even when Sabrina gets frustrated with me, I still like her. Huh? Josh? Well, I don't know about Josh. Yeah, I like Josh. All right. Listen, I have never met a student I didn't like. I don't like some of their behaviors. Tori?
So you were tired.
All right. Remember when we made the water molecule out of balloons?
Yeah.
Okay. What we found was, y'all really are kind of off the chain today. What is the deal? Y'all better be careful. I'm going to start jerking your chain.
Okay, come on. Shut up, Nigel, dang. He's going to jerk your chain.
I said let's talk. So you're going to sit over and shut up?
No, you ain't talking to me like that. You're really not talking to me like that.
Nigel, you give just as good as you get. I mean, you don't know who's to complain.
I'm trying to learn.
And I appreciate that. I really do.
You affecting your own self.
Hey. Shut up.
You affecting your own self.
All right, now if y'all calm down and listen, we'll try to go through this. Okay? It doesn't matter which side you draw it on. I could draw it on the top.
Does it have to do?
I don't understand them dots when I'm trying to learn. Really?
It's dotted lines. So.
You just show another one, dude. What?
It's just showing that it's a...
I can't understand.
It's showing the one on the back side of the triangle.
They're not dots, they're called dashes.
This is awesome. I don't know what
Well,
else.
obviously Mr. Competitor doesn't care about it would do that.
You know what, Nigel, really, they really are helping you if you just listen. Okay?
You're
Okay.
busy talking.
Well, okay, calm down. Shh. Y'all can all work together if you'll try. All right, now, so if you do, listen.
Okay.
All right, look, do I need to start writing people up for talking out? Come on. Either get it together or be quiet. All right? I want you to help each other. The responses are good, but you know, you could be a little bit nicer, all of you. Okay? Can't we just all get along? Okay. Now look. Please listen. Water has an uneven arrangement of bonds. When we finish with the whole series here for predicting the shape of water, that's uneven. Okay? If it was linear, where I had an oxygen here and a hydrogen here and a hydrogen down here, that'd be evenly arranged. Okay? But because I kind of got it bent around a little bit, that's an uneven arrangement of bonds. Okay? So that's one of the two requirements for a polar molecule. Well, the only thing we need to know now is whether or not these bonds are polar. And here's what we use to figure out whether the bonds are polar, right here. Electronegativities. That's how we figure it out. And guys, it isn't hard. If you'll listen, you'll get it. It's not hard.
How come I didn't get one of those?
There should be one in there.
The ones you gave?
Underneath the polyatomic ions. You got polyatomic ions, don't you?
Oh, I know what I got. Oh, well. And that's
Right there. It's right there. It's right there. Okay. All right. Now, what we're looking for to determine whether it's a polar bond is the electronegativity difference. We're looking for the electronegativity difference.
for the N.
Right. The electronegativity difference. Well, the electronegativities are listed here. How do you find a difference? Yes. You subtract. Okay, all right. So here's what we're looking for now. A polar bond,
Why did you put
the electronegativity difference. Okay? And a polar bond will have an electronegativity difference between 0.5 and 1.5. Okay? Polar bonds have an electronegativity difference from 0.5 to 1.5. Okay? You would subtract them. So the bonds we have are those between oxygen and hydrogen, and we have a second bond between oxygen and hydrogen. We need to know what those electronegativity differences are. So you just have to subtract.
1.3.
Hmm?
Talking about E is 1 or negative 1?
Because it depends on if you subtract the point.
Oh my God, you're not.
You subtract this number from that number.
Next to polar bond, 0.5
Oh, so you already have it.
Oh, the difference is between 1.5 and 1.5. So anything in between there is going to be what we call a polar bond. Okay?
Have an exact number.
There isn't one single number. It's a whole range of numbers.
Oh.
How do you decide?
If it comes out to be between 0.5 and 1.5, it's a polar bond. Let's do the subtraction.
Yeah.
Take 3.44, that's the electronegativity for oxygen. So oxygen's electronegativity is 3.44. And hydrogen's electronegativity is 2.1. And we're going to subtract those to find the electronegativity difference for this oxygen to hydrogen bond. Yes.
What is that beside the A? Is that associated to?
Here?
Yeah.
En, electronegativity.
Above that, the little line.
Oh, this is supposed to be an equal sign.
Oh.
My marker's getting kind of worn out here. Need to get a new marker. But I'm cheap, so I try to wear them out completely before I do it. All right. So you said, what was it, 1.34? course, what are we supposed to do because of this empty slot right here? So the actual number we're looking for here is 1.3, and that's the electronegativity difference from oxygen to hydrogen. Is that between 0.5 and 1.5?
Oh, so it's always in between 0.5?
Yes.
Okay.
Yes. So if it's in between there, those are polar bonds. Okay, let's go back up here to our list. Do we have polar bonds? Do we have an uneven arrangement of bonds?
Yeah.
Ding, 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 ding. We have a polar molecule. Got it? Polar molecule.
How do you get the unevenly arranged?
You look at them. You basically got to do. It's got to just figure out what is an even arrangement. Yes. Yeah. Even arrangement is three-dimensionally symmetrical.
So is it
Okay. Listen carefully. And sometimes it's hard for students to understand. Has to be three-dimensionally symmetrical.
and 1.5? If it's anything out of it, no.
An even arrangement is three-dimensionally symmetrical. Okay. Now there's a lot more. It gets a lot more complex than that. I mean, the math can get pretty intense. Okay. But 90% of the time or more, you can make reasonable judgments just by looking at the shape of the molecule and determining the polarities like this. So the vast majority of polarity situations you need to consider, it's really pretty simple, straightforward stuff. Okay? Don't make it harder than it has to be. All right. Huh?
Alright, homework. Oh my god.
Do we have to, Mr.
Yes.
Do we have to do all of that, like the tetrahedral thing?
What we told you about right
Yes.
the whole thing out. Check.
I'm talking about like when we do a problem.
Yes, that's a tetrahedral right there.
When are you gonna realize?
All right, there's your check yourself problem. Okay, you have a problem. Tori, go to work.
I'm going to work after school.
Tori, go to work on this problem, or I'm going to go to work on you now. Come on.
So you don't subtract anything on this one, right?
Well, you will have to subtract eventually. Maybe.
To find out.
Yeah.
I'll go to work Thursday.
Oh, because
Less talking, more working, please. Less talking, more working, please.